right, good morning, 4 months. You guys are doing great, right? I don't really think there's any problem that you're facing, you guys. All right, so today we'll proceed with physics. And apparently, we'll do something that you've never thought you'd be done in physics, that is describing atoms. Who thought about it? Physics is not the study of atoms, but right here we are discussing atoms. That's confusing to some, but okay to most of us, yeah? Sure. That's great. So today we'll proceed to look at potential energy or stored energy. So we saw that one of the forms of stored energy was, we saw that it was, we started with gravitational potential energy, then we looked at strain energy, which also we called elastic potential energy. So just to remind you guys, we said gravitational potential energy refers to the energy possessed by any object or material that is above the surface of Earth, such that if something is holding it and you remove that thing which is holding it, apparently it will fall to the ground. Okay, and we also said that strain energy is energy that is possessed by elastic materials that have been stretched, compressed, bent, twisted, and even squashed like a balloon. Yeah, so yeah, those are the examples. For example, an elastic band, which when you stretch it and you release it, it will retract back to its shape. All right, so that's strain energy. So the other name for strain energy, we say it's elastic potential energy. And remember that all these are under stored energy. It's stored energy. And the last form of stored energy is chemical energy. So today we'll look at chemical energy. So what is chemical energy? So before I define it, let's just read a bit. It says energy can be stored in the chemicals from which a material is made. All right. So if you look at any material, we do know that materials are made from chemicals. Materials are made from atoms, okay? That's what the second sentence is saying. The chemicals are made from atoms that are linked together to make molecules. Okay, did you know that anything that you see on Earth, anything, be it a paper, be it a plastic bottle, be it a wedding ring, be it a wooden board, whatever it is that you see around is made from atoms. And atoms are very small things, like literally small things you can see with your naked eyes. You can't even see with a microscope. Even the most powerful microscope can see an atom, because even the microscope itself is made from atoms. All right. Now, and just by the way, atoms were discovered by, the term atom was discovered by a man called John Dalton back in the 1920s, a long time ago. All right, so atoms make up all the materials that you see around, and apparently these materials, since not only one atom can make all the materials, so you have a lot of atoms, thousands, millions, even billions, quintillions, quadrillions, sextillions of atoms making up an object or a material. For example, if you look at your pen, okay, the pen, and then you take the cover of the pen, trust me, there are trillions and trillions of atoms making up that small pen cover. All right. Now these atoms are linked. Okay, they are linked. It's like they hold hands, so that they should make a material as you see. And when they link up, they make what we call molecules. So when they link up, they make what we call molecules. All right. So let's go ahead and see. So the chemical energy is stored in the links between the atoms. All right. Now, since we're saying that these atoms are linked up, they are linked up by what we call bonds, chemical bonds. So, for example, if you have one atom and another, so there is a link in between the two. And apparently that link is known as a chemical bond. All right. Now, in these chemical bonds, which link one atom with another, that's where you have energy stored. Okay, did you know that? So energy is stored in the links between the atoms. All right. Now, let's read on. It says food, fuel, and the chemicals in an electrical cell or battery are examples containing stored chemical energy. I'll just skip that. So let's see how the energy is released. Remember that energy is released from objects having gravitational potential energy just by removing the obstacle that was holding them. And energy is released in objects possessing strain energy if you remove the force that is either stretching them, squashing them, compressing them, or whatever it is, or even bending them. Now, for chemical energy, the energy is released when the links between the atoms are broken and the molecule in which the energy was stored is broken down into smaller molecules. Okay? Now, if you had, let's give an example of a pen cover. In the pen cover, you have atoms which are linking together. Now, if those atoms between the links, there's a link, like I said already, which is joining two or more atoms. If those links are broken, then the energy, which is chemical energy, is released. And I want you to know that the links are broken through what we call chemical reactions. I'll give you a very basic example of a chemical reaction, because maybe you're like, I've never seen a chemical reaction before. But trust me, you have. Because one basic example of a chemical reaction is burning. You're like, what? Yeah, burning. When something is burning, that is a chemical reaction. Okay, I will not talk much about it, but yeah, okay. Now, that's one example of a chemical reaction. Burning. All right. So, for example, if you have a piece of paper, in the piece of paper, you have atoms which are linked. And in those linkages, you have chemical energy. If you burn that paper, the energy will be released as heat energy. Do you see that? That's why when you're burning something, there's heat produced, because it is the energy which was between the links that's being released. So burning. Another example of now, before I proceed, I want you to know that there's a word called fuel right here. Fuel. And fuel is anything that burns. You're like, what? We thought fuel was petrol. Yeah, petrol is an example of fuel because it burns. But even wood is fuel. If you talk about paper is fuel because it burns. Anything that burns is fuel. So it means fuel will release its chemical energy by burning. Another example of a chemical reaction is respiration. Do you know that when you breathe in oxygen, the oxygen will react with carbohydrates in your stomach, and it will release energy that you do things with. So you can jump up and down, you can talk. Even the energy released, some of it is turned to heat. That's why when we hold your stomach or the area underneath or within your neck, there'll be some heat produced there. It's because of this respiration reaction which is happening. So two examples of chemical reactions: respiration and burning. Okay, otherwise today let's stop right there. Okay, let me just look for this. All right, so what I'll do is I'll just attach. Should I attach? Yes, I'll attach. I'll see about it anyways. But otherwise, all the best. And when I feel like, I would just attach an exercise in the next lesson. All the best. Yep.